Okay, thank you, and welcome everyone to this tutorial where we are going to talk about, rather have a hands-on tutorial on how you can set up an automated update to your Shiny dashboards if you've deployed them on Shinyserver. So allow me to share my screen. Just screen. Just let me know once you are able to see my screen. Can you see my screen?
Not yet.
Not yet. Just how about now?
Yes, yep, you're sharing. Yeah, we can see your slides now.
You can see my slides. Good. Okay. Me then. Okay. So yeah. So in this tutorial, I'm hoping that we've already interacted with, or rather, we've built dashboards using R. If not, then I believe that we can find tutorials online on how we can develop dashboards using R. You could use RStudio and R install on your laptop, or even VS Code as the GUI tool to develop your dashboard. So Shiny is a framework in R, which you can use to develop your web applications. And depending on your use case, it may be necessary to expose your application to the web for people to access your application remotely. And there are different ways in which you can deploy your application, your Shiny dashboard for that matter. You could use shinyapps.io. They have both a free tier and a paid version, where in the free tier you can deploy up to about, I think, 5 dashboards, and you have to up to 25 hours in a month to access your application. There's also the option of deploying them using Shiny Proxy, which is an open source system that gives you enterprise features. And that's a good thing with Shiny Proxy. The downside to it is that it's a bit complex to set up the system, given the use of Docker and Docker Compose to have your applications Dockerized and deployed as Docker containers. There is also the option of deploying your Dockerized applications to cloud platforms, the likes of DigitalOcean, Fly.io, and others as well. And also you can use POSIT and Shinyserver. Now Shinyserver comes, there's at the end the open source version, and there's also a paid version, which comes with more features that you wouldn't find in the open source. For this tutorial, we are going to look at the open source Shinyserver option, but of course, feel free to explore the other options to have your applications deployed. Now, I had sent some instructions on a GitHub repository that I put together, instructions that you needed to check to do some preparations ahead of this tutorial. And one of it was installing Shinyserver. There is, I provided a link on to the Shiny server configuration guide, which is accessible on POSIT's documents, which can help you to set up Shinyserver on your server. And the good thing with Shinyserver is that you can host multiple applications on your Shinyserver, but then each application will be assigned a unique web address such that whenever somebody visits that address, they'll be able to see the respective application. When you install your Shinyserver, this is what the directory structure looks like. By default, it's installed in the /srv section of your Linux. And also to mention that this Shinyserver can only be installed in Unix operating systems. And for this case, we are going to look at an example of an Ubuntu version of Linux. And inside the SRV, you'll have the Shinyserver folder, which comes by default with the index.html sample applications. And inside the sample applications, you'll have the hello, which is a Shiny application, and RMD, which is a markdown document, just to let you know that you can as well deploy your markdown documents on Shinyserver. So this is how your directory structure will look like. So now, up until this point, we have you've developed your application using RStudio VS Code, depending on which tool you use to do your development. And I'm assuming that we already have our Shinyserver installed. For those of us who are able, who have Linux operating systems, or even those who have virtual machines pinned up on your Windows, because you can as well spin up a VM on Windows using the likes of VirtualBox. So now you have Shinyserver and you've developed your application. So there are different ways in which you now need to upload your code repository for your application to Shinyserver. One alternative is you could use software such as FileZilla to upload your code repository onto Shinyserver. Another alternative is that you can use GitHub. Of course, you'd have Git installed on your laptop, and then once you develop, you create a repository on GitHub, and then you upload your code repository to GitHub. And then now you'll have to log in to your server and then now pull your repository onto the server. And that's the default way, or rather the way that I suppose most of us are potentially using to deploy our Shiny application. Now, as much as yes, using the software such as FileZilla is an option, the other alternative, which is using Git and GitHub, gives you more features, such as the capability to collaborate with your colleagues at work. Say you're working on the same project. So the beauty of Git and GitHub is that you can collaborate and keep versions of your code repository to which you can revert to at any point. And then there's also the beauty of having your code secure on cloud. And now the third point is what actually brings us to this tutorial, which is the possibility of setting up an automated workflow. So this is only possible if you have your code on GitHub. So then, so now I think we can get to, get our hands dirty with having a simple Shiny application in a GitHub repo, and of course ensure that we can be able to send updates from locally on our laptop to GitHub. And then of course we're going to proceed to see how we're going to set up a webhook to send the updates, push the updates onto the server. So so now here's just allow me to go to, this is my GitHub repository, and I have my I'll have my demo. I think it's this demo Shiny application. I had already set up this demo Shiny application. It's just the old faithful Gazard application that installed by default when you create a Shiny application. So locally, this is my application locally on my laptop. So now I have a VM that I've spinned up on VirtualBox, which I'm going to use as my server. And then now my Windows laptop is going to act as now my development environment where I'll be developing my application. So this is the application. And if you run it, I guess, so this is what comes up when you run the application, just the simple application. Now I'll make a simple, just a small change. I could just edit the title of this application. And then I have my, I hope you're seeing this, my screen as using different windows. Then I'll bring up my my bash, then I do git status. This is the process you would ideally follow. And then I made a change on my UI.r. Then I could do git.r, add, and git commit sam. Then I could just say update one. Then that's the commit, and then I do git push. Just to ensure that the connection from my local repository to the remote repository on GitHub is working and it's well set up. So that is the git push. It's gone. If I go back online and I do a refresh, I should see a recent update to. There it is. If you look at the commit, there's the update one. As I indicated on the git commit. So, well, we have our application locally, we have our remote code repository working and the connection is working well. So we can now go to the next bit. So like I mentioned, just to recap, is that what we would do normally is after we've done the git push, you would log into your server and then I'll manually do a git pull. But there are ways in which you can set up an automated workflow that works in such a way that you don't have to manually log into the server to do the git pull. And there are two alternatives. There could be more, but I know of two alternatives. And one of it is setting up a cron job on cron tab on your Unix system. And the cron job works in such a way that you can set up a script that runs at specified time. And so you could set it up to, let's say, run at midnight and run at after every 5 minutes. But the challenge with this is that normally the way we do our development, it's quite spontaneous. And so, you know, setting up a system that runs every other 5 minutes when you've perhaps not made any change for a whole week, it's not, it's needless. So so that can work, but now it depends on how how you operate or how you do your developments at your workplace. The other alternative is to set up a webhook. So let me explain the difference between a webhook and a poll. A webhook and a poll, in this case, a cron job is a type of a polling. So the polling works in such a way that you have your application and your endpoint. So your application, you know, keeps on sending messages to the endpoint to check if there are any updates. So if you set up your cron job to run after every 5 minutes, so after 5 minutes, there'll be a message sent, hey, is there any update? And then the endpoint returns a response, no. Is there any update? No. So it keeps on going in such a way until when there's an update, and then that will be returned back to the application. Now, the webhook works in such a way that you will register your webhook and let your endpoint know that whenever there's an update, just send me the update or do this or do that. So that is the difference between the way a cron job works and the way a webhook works. Of course, there are webhooks in different systems. GitHub has a feature which has webhooks, and so GitHub webhooks provide a way for notifications to be delivered to your external web server when certain events occur. So for you to set up this, you will need the endpoint to which a payload is a JSON file which is sent by a webhook. So you need an endpoint to which the payload will be delivered. And you will also need the trigger to invoke the payload to be sent. And we are going to get to setting up the webhook. So I'm just taking us through, and then we are going to get our hands on to doing it. And then now the endpoint, in this case on your server, you will need to spin up API. I went for Django REST API, but you could as well set up a Flask or Fast API or even a Plumber API. Only that, of course, there are differences. I'm yet to really try Plumber on a production environment, but there are, of course, challenges that comes with Plumber, the way R is single-threaded. So depending on how overwhelming your workload could be, then you might get such challenges. But then I believe there are the ways around it, which I haven't tried, and that's why I went for Django REST API. Now, once you have your Django up and running on the server, you could spin up, or you could, use web server like Nginx to reverse proxy calls to the API. But for this tutorial, we're not going to configure Nginx. That's left to you to go and set it up and put your API behind Nginx, so that calls will need to pass through Nginx to get to your API. But then once you have your API running, it's going to, of course, to use a port. You can use the address to your server, and then, of course, full colon the port number to be able to access your API. And so if you went through the instruction, then did set up a Django API, this is the folder structure of your Django API. It has many files within. There's the app folder and the project folder, the settings.py, where you do set the global settings for your applications, the URLs. There's the URLs in the project folder and the URLs in the application folder. The URLs in the application folder are the ones which direct you to the views, the endpoints. Let me call them endpoints, of which now the URL that the user hits on will take them to a specific endpoint. So that is the URLs, and then there's the views, like I've mentioned. That is where now you define your endpoints, your functions, and whatever they do. And you'll have the settings.py. This is where you register your application. This is just a bit of a recap, but more instructions are given on the repository that I've shared. You'd find more instructions and guide, or rather details there, on which each of the files do, and of course how to set up your Django API. And then there's the urls.py of the project and the urls.py of the application. I've created an endpoint which I've called git pull, which is going to perform the git pull when a payload is sent to this API. And then there's the views or the PY of the application. This is where now, so what happens is when we will set up a webhook, it's going to send a payload to the Django API. So it's going to hit, this git pull function that I have defined, which is an endpoint. Inside it, I'm calling a sub process. So sub process is a feature where you can invoke, CLI commands and run things on your terminal. Of which, in this case, what we want to do is just to run a bash script, which in turn is going to perform a git pull to bring the changes from GitHub to our Shiny server. So this is the sub process. This is how you invoke a run. You invoke a sub process. The script .loc is just an environment variable which has a path to our bash script. You could just define the path to your bash script directly inside the square brackets, of course with the quotation marks, and it is going to be run. So that is the need for, that is the reason why we had to load .env, but you could do without it. So so when setting up the webhook, you need to specify the event that will trigger the payload to be sent to the endpoint. I'm going to show you how to do that. For this case, we are going to use a push event to our repository, which is going then to send the payload to our API. But you could set it up to be triggered by pull request, creating a branch when an issue has been created on your repository. But for this case, a push event sounds a good way to trigger our webhook. So I think allow me to now log into my repositories. So here we are. You go to the settings, and then under the settings there is this webhooks. It comes under the code and automation. Click on webhooks, and then when you come to webhooks, as you can see, I already had a webhook set up, but ideally you would not have anything. I could just delete it. So by default, this is how you go. This is where you're going to land, and then you're going to click on add webhook, and then in the payload URL, this is where you put the URL to your server. I'm going to show you an alternative way to create a tunnel to your VM to expose it to the internet. If you don't have a domain name and all that setup. And then under the content type, you will select application JSON, a secret. If you set up a secret on your GitHub, you could just put it there, or but you could just do you can bypass that. And then you by default it comes with a SSL verification. And then this is now the section which I was referring to, that you need to select the event that will trigger your webhook. So the default is just a push event, which we're going to use. But if you want to set up a webhook for other functions and other automations, you could just come to let me select individual events. And then down here, you see you're going to have branch creation, branch or tag deletion, and fork, if somebody forks your repository, issues and issue comments, labels, so many things that you could set up. So we're just going to use the push event. So that's how you set up your webhook on your Shiny application, or rather your repository. So that's it for the webhook. And then so allow me to, I think, get our hands dirty. Show you what so this is my VM. Hope you can see it. I'm going to log into my VM, and what I'm going to do is I'm going to set up the Django. So this is the Django API. This is Terminator. So I've split up my terminal into 4 panels just so that to make it easy for me to operate and spin up my Django API. So let me first of all deactivate. So you'd ideally activate your virtual environment. So I'm assuming you've already set up your virtual environment with all the libraries that you need. So you use source./ your virtual environment, and then you activate your virtual environment, and then you can use Python manage.py run server. All the instructions are on the repository that are shared, and then you hit that, then it's going to spin up an API which is listening on port 8000 by default. So 127.0.0.1 is the address, which is the localhost address of my VM. Now, seeing that I don't have nginx and domain name and what have you, I'm going to create a tunnel to my VM, which is going to expose the VM to, just so that the payload which is sent from GitHub can be delivered. Now, I'm only doing this for demonstration purposes, but on deploy or on production, you definitely are not going to do this. I'm assuming you'd have your server set up with the domain name and then your server. So this is just for demonstration purposes. So I'm using a service called localhost.run. You can use that also. What it does, it creates a tunnel to your VM, which gives it a unique URL that lasts for about 15 or 10 minutes. So it keeps on changing after every 10 or 15 minutes. So allow me to hit on this. Before I spin up, before I create a tunnel to my, if I create a tunnel to this, I think it would be good to show you my Shinyserver. So this is where my, okay. So let's say you are home. If you want to access your Shinyserver, you go to srv Shinyserver. Then you get in your ls.lh. As you can see, my Shinyserver has applications, demo Shiny app. This is the application which we're going to use. If you just seed into demo Shiny app, then your ls.lh, you're going to see there's a git file there which identifies this folder to be a git repository folder, and then there's ui.r, server.r. Yeah. And then another thing I want to show us is if you go to the browser, this is that demo application. I'm just serving it locally. So if I just refresh, so this is it, all faithful Gizzard data. Then there is the bin there which you can play around with. So this is how you access your application on your Shiny server. Give the URL, the port, then the folder name. So that's it. And then another thing I'd like to show us is the Django. This is my Django API. Just call it Django. So you have your REST API application, and which you could, the manage.py, this is what you use to spin up your application. If you go inside, I want to show us the views.py because, so this is it. Sorry, it's a bit cluttered. I was just trying out something which I'm going to explain at the end, but this is how you define your endpoint. And then the process here is going to invoke a bash script, which is located at this point in this address within my VM. So if it's successful, it's going to return success. If it's fail, it's going to return fail. So this is our views.py. And then I'm going to show us our bash script. This is the bash script. If I open it, so what it does, of course, there is logging. It logs a file, the log file in this location. We're going to check. And then, so what it does, it navigates to Shinyserver within the Shinyserver folder. And then it checks if the repo has a .git folder. And then if it does, it has a .git, then it runs git status and git pull. If it doesn't have, then it skips and says returns keeping because it doesn't look like it has a git folder, which essentially means it's not deployed on GitHub. So that's it. Those are the components that we need. So now I think I can go back to my Terminator, and now I'm going to create a tunnel and then take the URL, go to GitHub, and then configure webhook, and then now make a change locally on my laptop, push the change to GitHub, and then see if that is going to trigger the payload to get to Django API, which in turn is going to invoke the bash script. Just before I do that again, allow me to just go. This is my logs folder. You'd ideally keep logs just to see, what happens when you run your system, and if anything fails. It's easy to debug when you have a log file. So this is a log file which was logged when I was just doing my testing, but I'm going to delete it, and then we're going to delete it, and then we're going to check this folder to see if we're going to have a log file there. So this is it. I'm now going to create a tunnel to my VM. So this is it. It's done. So this is the URL. Just going to take this URL here, this one, and then this is what I'm going to configure on GitHub. So I'm going to just go back to GitHub, and then here is it. Let me set up the URL. So it's this is it, and then I've selected application JSON, enable SSL, right? Just push event, and then that's it. That's all you need. So once you've defined this, just checking if it's correctly this correct. Then I'll add a webhook. Just click on add webhook. You see it returns, it says that, okay, that hook was successfully created. We sent a ping payload to test it out. So, and then if you, let me show you. If you go back to your VM, if you look keenly, there's a post request which has been registered on our application with a return code of 200, which is successful. And I could now go locally, then change my application. Could just change it, simple shiny up, and then just a minute. Make a change. Git status, and then git add, and then git commit, make a change, update to. Okay, then I'll do git push. Git push. Okay. There goes, gone. So we can just get on and check our webhook. So this is our webhook. So what you could do before you even get to the server, you can just click on your webhook and you go to recent deliveries. And then if you click on recent deliveries, it's going to tell you if your deliveries were sent. If you see a green tick here, it tells you that it was successful. The first one was the test payload that was sent to test if the API is working, if the payload, if the webhook has been set up and your endpoint is actually accessible. The second one is the one that I've just sent, which is updating our application. So now we can get back to the server, get back to the server. Here we are. As you can see, there's another post request which has been sent to our API, and it returned code 200 to mean that it's successful. So what I'm going to do is to, first of all, get to the logs, get into the log. I had deleted the bash script log file, but you can see there's a new log file here, which I could open and see if anything happened. And as you can see, there's an update in the log file indicating what happened on the bash script. So like I mentioned, the bash script, what it does, it loops through all the folders within Shinyserver and checks for the .git, which identify that folder to be a Git folder. If there's no .git, then it skips that and then to the ones which have .git. So that is why it returns this, updating this, your branch is up to date, and then there's this update which was sent on this specific application. And then it goes on to skipping the rest of the folder because they don't have a .git file inside. So that is the log file. Another thing you definitely want to check is to see if your application was changed instantly. So this is our browser on the VM, not on my laptop. If I remember what I changed, the only change I did is just to change the title of my application. So I'll just refresh. Kaboom. And as you can see, the title has changed. So this is an instant update, which has happened without me necessarily having to get into the server to, manually do a git pull to update the changes to my application. So this is an instant system which we've set up, which instantly updates our dashboards deployed on Shinyserver. So I think that's it. I will allow for questions given that I see we have about 15 minutes to go. So I'll, open up for questions, and then I'll do the closing comments on potential further developments which you can do on this system. Say if you want to use it on your production setups. So do we have any questions? Okay, I guess silence means we do not have questions. So I'll just proceed to talk a bit on further developments that we could do on our system. But before that, I think it would be nice to, oh yes. So one thing I forgot to mention is that for your bash script to be accessible or to be executed from the API or using the API, you will need to make it executable. And the way to do that is to use the change mode, which function is command is chmod plus x, and then the script name. So it makes it executable. And then let me show you. Just let me go back a bit to now. If you go to, sorry, if you go to, if you notice, let me show you. If you notice, my bash script .sh is in green, which identified to be an executable file. There's also another test bash script .sh, which is similarly a bash script which you can use for test. When you're setting up this system, you definitely don't want to go straight into running a git pull. You might want to do a simple test bash script which just does a simple arithmetic equation 1 + 1 and then returns you the response. And then once you have that set up, then you can now proceed to set up your bash script which now does a git pull. So as it appears in green, it means that it's executable. So So that's one thing I forgot to mention. And then, so this is now our ultimate system architecture. So you have your code repository local to your laptop, and you make your change. You do a git push, which sends the changes to your remote repository, which is sitting on GitHub. And then on GitHub, you configure your webhook. I showed us how to configure the webhook, which then sends a payload. Now, it could go directly to the Django REST API, but like I said, you could set up your Nginx web server, which then acts as a reverse proxy to the applications which are running on your system. And then so it reverse proxies the calls to port 8000 where Django REST from Django API is running. So when it hits Django, remember our views.py, which has the endpoint, essentially a function which we defined, which is invoking a sub process, which in turn is running a bash script. So the sub process runs a bash script, and inside the bash script, what it does simply is just to perform a git pull, which then updates your code which is sitting on Shinyserver. The bash script, you could have it sit inside Shinyserver, or you could have it sit elsewhere, and then you point it to the repositories which are in Shinyserver. Another thing I'd like to mention is that you can set up your Django API to run on systemd, to run as a system process, in such a way that, because the way we've spinned up our Django API, if by any chance anything happens to our server and it's down, when your server restarts, it's not going to restart your application, your Django API by default. And that's now the need for you to configure it to run on systemd, such that it runs as a system process. So whenever anything happens to your server, when it's restarted, it's going to by default also start your Django API. So those are further developments which are mentioned that you might need to, of course, take into consideration as you're setting up your system. And then another thing is that you can as well, there's a command which you can use to spin up your Django application to run as a background process. So what that means that it doesn't close out your terminal. For me, I was able to navigate and use because I'm using Terminator, but ideally what you do is just to spin it up to run as a in the background, but you can of course kill it if you want. That's another thing which I thought is important to mention. I see there's a question. To take the automation a step further, do you have a home page that references all the application deployed on your Shiny server? And could you automate the updating of this home page? Now, setting up a home page on Shiny server, it's actually one thing which I'm investigating. It's not straightforward. It's not straightforward for Shiny server. I'm investigating that in such a way that you can have a homepage which now has all your applications, and it's possible, if you already have such a homepage, it's possible to update it. So, and that is why actually, it's good you've mentioned, and that is why you see, sorry, this is getting a bit, allow me to just kill this. This is getting up, and then navigate to my Shiny server. So as you can see, As you can see, I have applications, I have demo, Shiny app, and home directory. This is what I was investigating. So I wanted the home directory to have the home page, and then to have the home page, and then put all your applications inside the applications folder. And then now what I was trying to investigate is a situation whereby now the URLs to the applications within the applications folder are then configured on the home directory application. But now for this to be possible, then you need to change the configuration of Shinyserver. Now, I was stuck at the point of changing the configuration of Shinyserver. I did change to make it such a way that it loads by default the home application, which is in the home directory, and then now, which then lists all the applications. Then when you click on each of the application, it just takes you directly to the respective application. So it's something I'm investigating to. I got stuck at the point of changing the configuration file of Shinyserver. So that was one. And the other question was, could you process automate the updating of this homepage? Yes, you can do that. If you can hack, in setting up that homepage, then you could as well update it automatically. So yeah, that's it. Any other question? All right. If there are no questions, another thing I think I thought is important to mention is your bash script. You could, of course, you could enhance it further to do even further checks. To do further checks on your folders deployed on Shinyserver, depending on your use case and how you'd want to set up your system. I've just remembered an important thing I wanted to mention is that the way the GitHub webhook works is that any push event to any of the branches of your repository will trigger the payload. But the ideal here would be a push event to your master branch, because I'm imagining of a scenario where you have your development branch where you're doing your tests here and there, or even branches which colleagues are working on, which could be many. And then you wouldn't want to poke your API every time there's a push event that is sent to a development branch, which is not the master or main branch. So by default, the webhooks will be triggered when you send push events to any of the branches. Now, the way around this could be now on the side of the API, you can further enhance your function to do a check. Remember, I said there's a payload which is sent to your. Let me show you how the payload looks like. Let me take this one. A payload is simply a JSON file which is sent to your endpoint, in this case, the Django API. So the payload will have the branch which is actually which is triggering the payload, which is triggering the webhook. The branch, which is you'll find in this the key value pair. It will also have the repository name, the repository name with the name of the owner of that repository, and every detail, the tags, blah blah blah, so many details about the repository. So what you could potentially do is to process this payload and do a check such that you only invoke the bash script when the push event was to the main branch. So that would lock out the push events to other branches invoking the payload. So that is the way around it. Another thing, which is a security measure, is you don't want anyone to poke your API this is just an enhancement of security. So what you could also do is, that is why I mentioned that my views.py file of the Django application was a bit dirty because I was trying out something. You can whitelist GitHub URLs because they have specific URLs for the webhooks. You can whitelist only those URLs so that, and then now you do a check on your another check on your API such that you only accept calls which are coming from GitHub. So that's another further enhancement that you can do on your API as a security measure, so, that no one pokes your API. So let me show you. I see we have 4 minutes. Do we have another question? Okay. Let me show you let me go to my Django application and then the views.py open. So this is what I was referring to. So what you do, you create a variable and then you put all the they are available online. If you check, you'll get the IP addresses for the webhook, GitHub webhooks. Then you list them here. And then what you do is that you take the IP address from the request, the request that comes to the API, then pick the address which is coming. And then now what you do now, a conditional check to see if that IP is one of the IPs in this variable. If it qualifies, then you proceed to run to invoke your sub process, which in turn runs the bash script. So there's potentially so many things that you can do just to enhance your API and your system. So if there are no more questions, I think we can close it at that, and yeah, take it back to James.
Cool. Thank you very much, Clinton. This was definitely, I learned a lot. Yeah. And the recording of this webinar will be available, and we'll also make sure to get any links from Clinton before that recording goes up so that you can kind of follow along if you're watching this later. So yeah, thank you very much for your contribution to the user community, and I wish everyone the best for the rest of their day. And we just, I thought we had a question, but anonymous attendee also says thanks. So yeah, thanks very much. And I'll close the recording now.